बिस्मिल्लाहिर्रहमानिर्रहीम अस्सलाम वालेकुम एवरीबॉडी। इस सीरीज़ ऑफ लेक्चर्स में हम बात करेंगे मशीन लर्निंग पे। सो वी आर गोइंग टू टॉक अबाउट एजेंट्स दैट learn from experience, that learn from examples with experience. Okay, so the videos that I'm going to make will be made from the content that I'm going to take from chapter 18 of the book, the recommended textbook that I gave you. You can see some of the content in chapter 18, and some of the content, especially the part of neural network, will be taken from another book which is called Machine Learning by Tom Michels, and I'm going to refer to the chapter that I am going to discuss, and that is chapter 4 of that book. And that book will be uploaded on Slate in due time. Okay, so you can see the relevant content in the chapter 4 of that book. So we are going to talk about, in this part, we are going to talk about the machine learning. Okay, so as I said, that in artificial intelligence we work in a number of areas. Okay, so we have discussed searching, we have seen different types of searches, and searching is one of the key attribute of artificial intelligence. Then I said that there are other attributes. For example, reasoning is one of the important properties of intelligence. Likewise, learning is one of the hallmarks of intelligence. Okay, so now we are going to talk about agents that learn with the passage of time. Okay, with experience. So the contents are at the beginning I'm going to give you some intro of what machine learning is. We will see different type of learning, and I will give you examples of different problems, and we will also discuss some of the learning algorithms. Okay, so we'll give you some discussion about the types of learning. So supervised learning, unsupervised learning, and there are some other types of. We will mainly discuss just the supervised types of learning, and there are a lot of famous algorithms which are related to supervised learning, but I'm only going to discuss the very basic algorithm, which is nearest neighbor algorithm, and currently the most famous class of algorithms, starting from perceptrons to multi-layer neural network to deep learning based models. Okay, and we are not going to talk about other algorithm like decision trees, naive bayes, boosting, and some other. No, we are not going to talk about them, because you may learn about these algorithms in some other courses. For example, maybe you will see them in data mining or in pure machine learning course. Okay, also I'm not going to discuss unsupervised learning. We will only talk about supervised learning, and I will give you examples related to supervised type of learning. Of course, we are going to discuss what the other types of learnings are, but mainly the discussion will be focused around the supervised type of learning. Okay, so let's start what learning is. So I would try to distinguish between learning and memorization. We know that computers are good at memorizing things. Okay, so computers have humongous memories, so they are good at storing data. We want to see what is the relationship between memorization and learning. So I would like to elaborate this thing with an example. So consider this example. Suppose that there is some child. Okay, and the child sees the faces of his mother every day. Okay, so in other words, I should say the child memorizes his mother's faces. Okay, he sees his mother in every day. Okay, so maybe 5,000 times, 10,000 times, but I have just pasted 3 images. Okay, so the child memorizes these faces. Okay, and learns that these faces are the faces of his mother. Okay, and after some time, after some days, he's going to recognize some other views, maybe in with a different posture, maybe with a different clothings, maybe with a different angle. Okay, he's going to recognize that the image or the face is of his mother. Okay, so I want you to think about it and tell me, what is the the that thing which the child uses to identify these images. I want you to pause the video for 5 minutes and think about what is that fundamental thing that this child uses to recognize different views, okay, different pictures or views or images of his mother. Okay, so I'm sure you might have thought of something, because for sure this is not just memorization, because if it was just memorization, so think about a computer. So instead of this child, think about a PC, for example, that stores this data. Okay, so if the PC stores these three images, and if you give your computer some other images, let's say rotated or with a different angle, so the computer is definitely going to say that these images are different from the images that you have stored. Okay, because it's going to, if it memorizes, it's going to compare them pixel by pixel. But that is not the case. Actually, the child uses something to generalize beyond what he has seen. Okay, I'm going to talk about what he's going to use. Okay, but the idea is he's going to use some characteristics in what he has seen to generalize on unseen data or on unseen examples. Okay, so I'm going to explain what this generalization is. Okay, but let's take another example. Okay, likewise, we have another child, let's say Nicholas. Okay, he learns about trucks and vehicles. Okay, so he memorizes a number of examples like before. So he sees, let's say, the examples, different examples in the real world, and he memorizes these are examples of a truck. Okay, so if you are going to give him another instance of a vehicle, he's going to recognize that that vehicle is a truck. Okay, will he recognize others? Yes, he will. Okay, so he's going to recognize that the toy that you gave him, or some other instance of the vehicle, if you show him, he's going to recognize them. Okay, so once again, he is going to recognize an object which is similar to the vehicle, but how he's going to recognize that, he's going to use something, and that something is, as I said, are the characteristics. Okay, and he will use those characteristics to generalize on unseen examples. Okay, so learning is not just memorization. Okay, learning is generalization, and generalization based on some features or characteristics. Okay, your agent or program, in this case I gave you the example of a child. Okay, so your agent or program is going to learn some features or characteristics from a set of data, okay, or given examples, and he's going to generalize it on unseen data or unseen examples. Okay, Likewise, if we go back to our previous example, the child sees the mother faces and he is going to memorize the features. For example, what could it be the feature? The features could be, for example, the colors of the eyes, the distance between the eyes, the shape of the nose, the color of the hairs, the color of the skin, and these could be different types of features that he is going to memorize. And if he is going to see unseen, okay, or new, let's say, instances, he's going to recognize that that instance is his mother because of the color of the eyes or the distance or the skin tone, etc. Okay, so learning is not just memorization. It involves memorization, of course, but learning is generalization. Okay, it involves both memorization and generalization. Generalization is to, once again, to use the learned features or characteristics to classify the unseen examples or unseen records. Okay, now let's formally define what learning is. Learning from systems point of view, learning denotes changes in a system. Okay, and remember, this system can be a software plus hardware system. So maybe you can consider a robot, for example. So learning denotes changing in a system that enable that system to do the same task more efficiently next time. Okay, so this is one definition of learning. Or you can define learning is a flexibility in the agent. So flexibility in the sense that it is constructing or modifying representations of what is being experienced by the agent. Okay, so learning makes the agent flexible because it enables the agent to construct and modify representations what he has based on what he has experienced. Okay, so from humans perspective, learning is the ability to make useful changes in our minds. Okay, so it is the ability to adapt, okay, to improve based on what you have experienced. Okay, so why it is useful for agents? Because this learning is the key hallmark of intelligence. It is one of the fundamental characteristics of intelligence. All intelligent being, they learn with the passage of time. Okay, and it involves taking data from the environment and feedback. So data and feedback, based on those, improve over time. Okay, improve the performance measure over time. Okay, if this activity, so the activity of learning, so for example, constructing, modifying representation of what is being experienced, if this activity is done by a machine, that we are going, then we are going to that machine is performing machine learning. Okay, so we are going to formally define what is machine learning. So machine learning is a process, okay, which refers to a system capable of autonomous acquisition and integration of knowledge. Okay, or we can also say that it is a process of building machines that automatically learn from experience. Okay, so machines that improve their performance by year with experience. Okay, this is one of the important area of artificial intelligence. As I said, machine learning is a hallmark of intelligence. Okay, learning is a hallmark of intelligence. So there are some example applications. So for example, a program that that learns with time to detect fraudulent credit card transactions. Okay, based on some patterns, based on some variation in activity, that program is said to be doing machine learning. Okay, so another program that learns to precisely segment some part of the body, so let's say a tumor area, for example brain tumors. So we are once again are going to say that that program is doing machine learning if it learns to precisely segment that part with time. Okay, Likewise, if a robot experiences some activity, and it sees some activity, it learns to conduct that activity, for example surgery, okay, then we once again we are going to say that that machine is doing the machine learning activity. Likewise, classical example is programs that learn, for example, the to detect the spam email. Okay, so we use these programs, for example, in our Gmail and other email applications. So programs that learn with the passage of time to categorize spam emails. Okay, likewise, another example is an autonomous vehicle that learn to drive on a highway. Okay, so once again, the agent, in this case the automated vehicle, improves itself with experience. Okay, so all these examples are examples related to machine learning. Okay, I am also going to give you another definition of machine learning with reference to the hypothesis function. Okay, a formal definition of machine learning. So let's assume that we are given several labeled examples of a concept. So for example, some images. So images are trucks versus non-trucks. Okay, so some images containing the object truck and some images containing some other objects, so non-truck objects. Okay, so these images or these examples, they are described by features. Okay, so features may include, for example, the number of wheels, the ratio of height and width, or maybe the size, or maybe the property of the vehicle. For example, it holds cargo, yes or no. Okay, so there are the examples are described by certain features. Okay, so mathematically we say a program is performing machine learning if it is able to build a hypothesis function that maps the examples by taking as input the features to a target variable. Okay, so a machine learning algorithm uses the examples to create a function which we call the hypothesis function that will predict the label of new examples, okay, or previously unseen examples. Okay, so machine learning is all about creating a hypothesis function, a function. You can say y is equal to f of x, a function like this, y is equal to f of x. In that case, f of x is our hypothesis and y is the target variable. So machine learning is all about creating this hypothesis function so that minimizes our error, or that improves the performance measure of the agent. Okay, and this is similar to a very simplified form of human learning. Okay, this hypothesis function is very important. Okay, this function can be of any type. So for example, this can be a polynomial. Okay, so maybe 3x squared plus 6x plus 7, for example. It can be a simple sine cos function. It can be, for example, a state-of-the-art classifier, for example, k nearest neighbor, or it can be SVM, it can be a neural network, or it can be a naive Bayes, or any type of classifier. So machine learning is all about creating a hypothesis function that, given some examples and features, maps those examples to a target variable. Okay, so machine learning is all about creating this hypothesis function. Now once we know what machine learning is, now we are going to see why we require machine learning. So there are some motivations that I have listed here why we require machine learning. So these are non-medical examples. So we require machine learning in areas where we don't have human expertise. Okay, so there are no human expertise, or human expertise cannot be applied. For example, in industrial manufacturing. Okay, So we require algorithms or programs that that learn the activity and perform that activity with the passage of time. Okay. Likewise, an important area is in the structural analysis or mass spectrometer analysis of different molecule. Or, and another example is the drug design. So, for example, uh, the analysis of proteins in the cells, okay, what activities they perform and how they can be activated or inhibited in the design of a drug. Okay, once again, the human expertise cannot be applied, so we may need machines that autonomously navigate that environment and act independently. Likewise, another example is astronomic discovery, where we require machines. So, for example, Mars rover, which autonomously goes to the area of our choice, for example, Mars, and autonomously navigates that environment. Okay. Likewise, we apply machine learning algorithm. We require a machine learning algorithm where there are black box human expertise. Okay. So, for example, face recognition, handwriting recognition, speech recognition. So we can't program, okay, because the the process cannot is ill defined, and we cannot program it with, and we the most suitable option is to use machine learning algorithms to identify these or recognize these type of classes. Okay. Likewise, other examples are driving a car or flying a plane. So once again, there are no defined let's say procedures that one can follow to write a program to autonomously drive a car. Okay, so this is something that is learned from the environment feedback and from autonomously perceiving the environment. Okay, so this is again an example in which we require machine learning algorithm. Likewise, we require machine learning for areas where there are rapidly changing phenomena. Okay, for example, credit cards scoring, financial modeling, diagnosis or fraud detection in real-time environments. Likewise, we also require machine learning algorithm for customization and personalization. The famous examples include for example, Microsoft Assist, okay, or some personalized newsreader. Siri is also a famous example of a personalized assistant. Likewise, the Siri is for Apple. This is an Apple's personal assistant, and likewise Microsoft's personal assistant is Cortana. Okay, you might have used this in Windows. Okay, so we need machine learning algorithms for personalization and customization. Okay, so these are the broader motivations in which you may require machine learning algorithms. Okay, likewise, there are one important area in which we require machine learning algorithm, so in which human expertise maybe are limited. So as an example, in medical image processing, to detect malignancy, okay, so different type of cancers, for example breast cancers, so we require machine learning algorithm as an example to detect micro calcifications, which are not I mean so trivial. Okay, you can write a program to just threshold an image and see these calcification in the image. Okay, so we require machine learning algorithm that learn this behavior in the images, okay, to detect these micro calcification in the image, or to detect some kind of lesions, okay, in the images. Okay, so this is something that cannot be hard coded. Okay, and this is one example. Another example is the classification of tumors into benign or malignant. Okay, by monitoring, for example, the oxygen and blood supply to the tumor. Okay, so once again we require machine learning algorithm to perform these type of activities. Okay, likewise, from robotics point of view, a robot that learns to perform surgery. Okay, so it sees doctors, how they perform, and it learns to act in that environment. Okay, so this is, once again, this cannot be hard coded. Okay, so we need machine learning algorithms to perform these type of activities. Okay, so this is the a key area of machine learning in which machine learning algorithms can be applied. Okay, so now I'm going to talk about the types of learning. What are the different types of learning? Broadly, we can categorize machine learning or learning into let's say 3 types. So first type is supervised learning. The second type is unsupervised learning, and then there is other types of learning. We call them reinforcement learning, or maybe some recommender systems, or some other type of learning. Okay, so I would like to define them one by one. So supervised learning is learning a mapping from a given set of inputs to a target variable. Okay, so supervised learning requires data plus labels. Okay, so supervised learning requires training data plus the target labels. I'm going to tell you with example in detail what it is. Okay, so there are 2 types of supervised learning. So first type is called classification. So classification is a type of learning in which the target variable means the thing that you want to predict with your algorithm, is discrete. Okay, so as an example, if you write an algorithm to filter emails into spam and non-spam emails, it's an example of classification. Okay, can you think of another example of classification? So maybe an algorithm that takes as input some image. So image may be of some vehicle, and it classifies that image into a particular category of the vehicle. Okay, so for example, an algorithm that takes as input an image and classifies the image into a car, a truck, or some other type of vehicle. Okay, so this is a case of classification. Likewise, there is, in supervised learning, there is another type which is called regression. In regression, the target variable, the thing that you want to predict, is real valued. Okay, so if your algorithm predicts the stock market, okay, so it predicts the level of the stock market, for example, or if your target variable predicts, for example, the intensity of the earthquake, in that case the target variable is real valued. So the value is going to be, let's say, 4 point something, 5 point something. Okay, so the intensity of the earthquake. Again, this is an example of regression. This is very important. Okay, so you should know the difference between classification and regression. In classification, the target variable is discrete. In regression, the target variable is real valued. Okay, and I give you some examples. Likewise, another type is unsupervised learning. In unsupervised learning, we have the training data. That means we have examples, and examples are described by features, but we don't have the target variable in the training data. In supervised learning, we have examples. Examples are described by features, and we also have labels of the examples in the training data. In unsupervised learning, no target variable in the training data. Okay, so an example of unsupervised learning is clustering. Okay, so for example, you are given data, so you are given examples with features, and you want to group them into similar groups. Okay, so consider for example a taxi agent, an automated taxi agent that is building the concept of good traffic days and bad traffic days. Okay, again at the back end it's going to use some clustering algorithm to cluster the examples, the example of days it has in its knowledge base. Okay, the third type of learning is called reinforcement learning. This learning is based on the feedback from the environment, okay, or the reward from the environment. Okay, so it's also a very important type of learning. So in reinforcement learning, the agent improves its performance by based on some reward. Okay, so consider for example a game playing agent that improves by taking feedback from the environment, maybe in the form of a reward or in the form of the increase in the performance per year. Okay, so these are broader three types of learning. Okay, then we have other types of learning. For example, we have recommended systems, we have many different type of other type of learning. Okay, so these are the problem. In this series we are going to talk about only the supervised type of learning, and we are going to see the algorithms that are under this title, the supervised learning type. Okay, so in the next video I'm going to talk about in more detail the supervised learning and some related concepts of this supervised learning. Thank you very much for listening.